Now come to the next question. That is question number 4. All of you open your textbook, my dear children. Every day, please be ready with the textbook and classwork notes. Okay. See the next question. Fourth one. Show that. Once read, my dear Joseph, read that question number 4.
Show that the relation R in R defined as R equals to ordered pair of A comma B, on which where A is less than or equal to B, is reflexive, transitive, but not symmetric.
Yes, very good. Thank you, my dear Joseph. Thank you for reading the question. See here, my dear children, a relation R is defined in the set R. Here, set R means it is a set of real numbers. Okay. In a set of real numbers, a relation R is defined as A is less than or equal to B. We have to show that this relation R is reflexive and transitive, but not symmetric. Okay, my children. First of all, a relation R in R here capital letter R denotes a set of real numbers defined as R is equal to set of all ordered pairs. R is equal to, all of you listen carefully, my dear children, how to read this sentence. R is equal to set of all ALL, okay, set of all ordered pairs A comma B, such that these two dots are read as such that. Please remember this point. Okay, my dear Joseph.
Yes, sir.
Please remember these two dots are read as such that. Previously, we have not read that word. Okay, such that A is less than or equal to B. A is less than or equal to B. Now, let us verify this relation R is reflexive. We show that R is reflexive, transitive, but not symmetric. Okay, my children. Right. Here we are proving that the relation R is reflexive. Here the relation R is defined in the set R, means it is a set of real numbers. Is it a finite set or infinite set? My dear Kevin Paul, can you tell me? Set of real numbers. Is it a finite set or infinite set? Kevin Paul, infinite set. So it is not possible. It is a very tedious job to write all the ordered pairs which satisfy the given relation. Okay, my dear children. Here the relation R is defined on an infinite set. So it is a tedious job. It is a difficult job to write all the ordered pairs which satisfy given relation. Okay, right. Now to show that relation R is reflexive, what is the first step? Do you remember that one? First step, we have to choose an arbitrary element. We have to choose an arbitrary element in the domain. Okay, my dear children, for this relation R, what is the domain and what is the codomain? Can you tell me, Jerome Jesli Raj, for this relation R, what is the domain? And what is codomain? Jerome,
So
just read
domain is a yes, sir.
domain.
Domain belongs to R, the relation.
Okay. What is codomain? What is
Codomain is B, sir. B. Codomain is B.
B? B. What? Anyone? Is it right? Is this answer correct? Codomain is B. He is telling. Jerome Jesileras is telling codomain is
Sir,
B.
both belongs to real numbers, sir.
Very good. Domain is real numbers. Codomain is also real numbers. Okay, my dear Jerome Jessliraj, please remember this one.
Okay, sir.
Domain is also set of real numbers and codomain is also set of real numbers. Please remember this point. Okay, Jerome Jessliraj.
Okay, sir.
Now, from the domain, we are choosing an arbitrary element, an arbitrary number, that is A belongs to R. This is the first step. After that, what is the second step? What I said previously, we have to write the relation R. In the given relation R, in the place of A, we write A, and in the place of B also, we should write A. Do you remember this step 2, my dear children?
Yes,
Reflexive
sir.
relation. Step 2, we had to write, we had to take that given relation, but we don't write given relation as it is. In the place of A, we write A. In the place of B also, we should write A only. Okay, my dear children. So, then what is the statement you get here? Can you tell me? Uh, Krupal, can you tell me? What will you get? What is the relation between A and B here? Tell me. But first of all, what is the relation between A and B? Can you tell me, Krupal?
Sir,
Krupal?
reflection.
Huh? Between A and B. I am asking you, between A and B, what is the relation defined? Between A and B. Between A and B, what is the relation defined here? Staines Johnson, can you tell me? Staines Johnson. Staines Johnson. Staines Johnson. Very good, Staines Johnson. A is less than or equal to B. That is a relation defined between A and B. Okay, my dear Krupal. Krupal, this is the
Yes, sir.
relation. Are you watching the screen? Are you watching the screen, Krupal?
Yes, sir. I am watching.
Yes, this is the relation between A and B. What is the relation between A and B defined here? Repeat that relation between A and B. Tell me, Krupal. Krupal,
Yes, sir.
tell me. Be active, my dear Krupal. Be active. What is the relation between A and B defined here? Are you concentrating
Sir,
here or what is the relation between A and B defined here? Krupal,
sir, B is equal to greater than equal to A.
it is not read as a greater than or equal to. It is less than or equal to. You are not listening the answers also. You are not concentrating here. Just now I asked Staines Johnson, he said the answer also, you are not paying attention. If you are not paying attention, no use of attending the class. Here I am asking some other students, they are telling the answers. You are not paying attention. Just I am asking the same question. You are not able to repeat the same answer. Then what is the use of attending the class? What is the use? Please listen. Please pay attention, my dear Krupal. Krupal,
Okay, sir.
please pay attention. Every sentence, every word is important in the class. Sir is not asking me, so why to pay attention here? Don't think like that. Okay.
Okay, sir.
Please listen carefully. Sir is not asking the question to me. Sir is asking some other students only. Don't think like that. Pay attention till the end of the class. Now, this is the relation between A is less than or equal to B. In this relation, what I said, in the place of A, we should write A, and in the place of B also, we should write A. Then what will you get? Ashwant Ram, can you tell me? If you write A in the place of A and B in the relation or between A and B, what will you get? What is the statement you get here?
Sir, can
Ashwant
you
Ram,
repeat the question?
if you substitute A in the place of A and B, what will you get the relation between A and B? If you substitute A, if you replace A in the relation A and B, what will you get? The statement.
Sir, I don't get the question. Replacing A, sir.
Huh?
Sir, A replacing A, sir.
A?
Sir, I don't understand the question.
You don't understand. Can you tell me, Janani? What is the second step? What I said in the relation A and B. What should we write? In the place of A, we should write A, and in the place of B also, we should write. Janani, can you tell me the statement now? Can you tell me the statement?
No, sir.
Hmm? Yes, my dear Joseph, can you tell me? Joseph,
Sir, A is lesser than or equal to A, sir.
very good. Joseph, you are following me. Very good. All of you listen carefully, my dear children. This is the relation between A and B. A is less than or equal to B. Previously, I asked you. This is very important. In this relation A and B, we are writing A in the place of A and B in the place of B also we write A. Then we get A is less than or equal to A. A is less than or equal to A. Now we have written this relation. We have written this statement. Now we have to verify, we have to check whether this relation is a true or false statement. A is less than or equal to A. Is it a true statement or false statement?
Sir.
For every real number, it is
The
a true
false.
statement. It is a true statement. If you take any real number, 4, suppose 4 less than or equal to 4, it is a true statement. Minus 3, if you take minus 3 less than or equal to minus 3, it is a true statement. So here, we got a true statement. Then what will you conclude here? A is less than or equal to A. We got here true statement. This implies that we can write ordered pair A comma A belongs to R. Yes or no? Ordered pair A comma A belongs to R.
Yes, sir.
Then what will you conclude here by seeing this statement? Ordered
R
pair.
is reflexive, sir.
Very good. R is reflexive. Therefore, R is reflexive. So the first part is over. Now second part. What is the second one? Symmetric. Let us show that. Let us show that R is not symmetric. Okay. To show that, To show that relation R is not symmetric, it is enough to give a counter example. It is enough to give a counter example. Okay, my dear children.
Okay, sir.
Okay, sir.
Let let us take two numbers 2 comma 4. Are these two numbers real numbers or not? 2 and
Yes,
4.
sir.
So we have taken two real numbers. We are giving here a counter example to show that relation R is not symmetric. Okay, my children. Now let ordered pair 2 comma 4 less than belongs to R. Then what is the statement here? 2 comma 4 ordered pair 2 comma 4 belongs to R means what is the relation between 2 and 4? 2 is less than or equal to 4. Yes or no?
Yes, sir.
Yes, sir.
2 is less than or equal to 4. Ordered pair 2 comma 4 belongs to R means 2 is less than or equal to 4. Suppose if you reverse these two numbers, if you replace these two numbers, then what will you get here? 4 is less than or equal to 2. Yes or no?
Yes, sir.
Uh, but 4 is less than or equal to 2 is a false statement or true statement? It is
False
a
statement, sir.
False, false.
false statement. So what will you say here? 4 comma 2. Ordered pair 4 comma 2 does not belong to R. Can you say that or not? Here we
Yes,
got
sir.
a false statement. Here we got a false statement. Therefore, we say that ordered pair 4 comma 2. Here we have taken two numbers 4 comma 2. But these two numbers are not satisfying. We got a false statement. Means they are not satisfying the given relation. So we say that ordered pair 4 comma 2 does not belong to R. Got this point, my children?
Yes, sir.
Then
Yes,
therefore,
sir.
what can you say here? For ordered pair 4,
Sir, R is
2,
not symmetric.
2 comma 4 belongs to R. Here ordered pair 2 comma 4 belongs to R. But ordered pair 4 comma 2 does not belong to R. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Reverse ordered pair. We have taken one ordered pair 2 comma 4, but its reverse ordered pair is not in the relation R. Then what can you say about this relation? Is it a symmetric
It's
relation?
not symmetric, sir.
It
It's
is
not symmetric.
because reverse ordered pair is not there. Yes or no?
Yes, sir.
Can you tell me the definition of reflexive relation, my dear? Jerome Jesliaraj? Can you tell me?
Sir, order pair A comma A belongs to R, sir. Belongs to the relation R.
That's all. Huh? Full relation, full definition. I'm not off. I'm not asking off definition. Full definition.
The condition is that the elements will be belongs to the set, sir.
Ordered pair A comma A belongs to R for all. For all A belongs to
For all
A.
A belongs to A.
That is a complete definition. You have said only half of the definition. That is why every day I'm repeating the same. All of you read, memorize the definitions well. Okay, please memorize the definitions well. Don't ignore. Yes. Now come to the next third one, transitive. Can you tell me the definition of transitive relation, my dear Grayson? Can you tell me transitive relation?
Sir, ordered pair A comma B belongs to R and ordered pair B comma C belongs to R. That implies ordered pair A comma C belongs to R, sir.
For all, why are you stopping the definition? For all A comma B comma C belongs to A. Okay.
Okay, sir.
Don't stop by ordered pair A comma C belongs to R. Don't stop it by that one. You should complete that definition. For all
Okay, sir.
A comma B comma C belongs to A. Understood?
Okay, sir. Yes, sir.
That is only one single line. You are not reading the definitions completely, my dear children. Read the definition perfectly without any mistake. Okay. So if ordered pair A comma B belongs to R, ordered pair B comma C belongs to R, implies that ordered pair A comma C belongs to R for all A comma B comma C belongs to A. This is the definition of transitive relation. Now, to show that R is a transitive relation, which type of ordered pairs should be taken? Do you remember which type of ordered pairs should be taken? Which type of ordered pairs? Transitive relation means link ordered pairs. Okay, A comma B, B comma C. Okay, my children.
Okay, sir.
Okay, sir.
Now let us consider ordered pair A comma B belongs to R and ordered pair B comma C belongs to R. Okay, my children.
Okay, sir.
Ordered pair A comma B belongs to R implies, how do you define the relation between A and B here? How do you define relation between A and
Sir,
B?
A is less than or equal to B, sir.
Very good. A is less than or equal to B. Let us consider this is equation 1. This result as 1. Similarly, ordered pair B comma C belongs to R. How do you write this relation between B and C? Can you
B
tell me?
less than or equal to C, sir.
Yashwant, can you tell me? How do you write the relation between B and C? Yashwant Ram. How do you write the relation between B and C? Yashwant Ram. Yashwant Ram. Yashwant Ram. Tell me the relation between B and C. We get to B is very good. Characters, very good.
Sir, can you hear me, sir?
B is less than or equal to C. Okay. So we got two results here. A is less than or equal to B and B is less than or equal to C. Then can we write A is less than or equal to C from these two equations? Can we write it or not?
Yes, sir.
From 1 and 2, we get A is less than or equal to C. Can we write this statement or not? From 1 and 2, A is less than or equal to B, B is less than or equal to C. So from 1 and 2, can we write A is less than or equal to C or not?
Yes, sir.
Yes, we can write. We get A less than or equal to C. This implies, how can you write this relation between A and C? Ordered pair A comma C belongs to R. Can we write it or not? A is less than or equal to C implies ordered pair A comma C belongs to R.
Yes,
Can we
sir.
write it or not?
We can write, sir.
Yes. So we have taken two link ordered pairs, namely A comma B belongs to R, B comma C belongs to R, and finally we got ordered pair result. Final result we got ordered pair A comma C belongs to R. Yes or no?
Yes, sir.
Yes, sir.
Then transitive relation condition satisfied by relation R or not?
Satisfied, sir.
Transitive relation condition is satisfied by the relation R. Therefore,
your answer x is equal to 1, right?
ordered pair A comma B belongs to R and B comma ordered pair B comma C belongs to R implies that ordered pair A comma C belongs to R. Therefore, we conclude that relation R
Any other answer?
relation R is transitive. Okay, my children. Therefore,
Okay, sir.
finally, what can you conclude? Therefore, relation R is
Why you didn't respond then? Is it later? You just come right next.
R is reflexive and transitive, but not symmetric. Understood, my children?
Yes, sir.
Hence proved. Okay, my children.
Okay, sir.
Now come to the next question. What is the question number 5? Question number 5. Read, my dear Johnson. Stans Johnson, can you read the question number 5? Read the question number 5. Stans Johnson, read the question. Stans Johnson, read the question number 5. Stans Johnson, can you hear me? Stans Johnson. Stans Johnson. Yes. Previously, I told you, my dear children, please be ready with the textbook.
Sir, can you sir,
Okay, Stans Johnson, read now. Read it now. Question number 5.
check whether the relation R and R defined by R ordered per A comma B is less than or equal to B cube.
That ordered pair A comma B such that, don't forget, read that
Such
two
that
dots. Such that
A is less than or equal to B cube,
uh,
reflexive, symmetric, or transitive.
so here, okay, thank you, my dear Stans Johnson, for reading the question. See here, question number 5. A relation R is defined in set R. Here, set of real numbers. R means here, set of real numbers. How the relation R is defined? Ordered pair A comma B, set of all ordered pair A comma B such that A is less than or equal to B cube. Okay, my dear children.
Okay, sir.
Right. Now, let us verify. Let us check whether this relation R is reflexive, symmetric, and transitive or not.
So one is so our trial one
To check, what is the first step to check the reflexive relation, my dear children? It is not a reflexive, so it is not a reflexive relation. So to show that this relation is not reflexive, we are giving a counter example. Okay, my dear children, let us give a counter example.
Dx plus 1 by 2. Right? So transposition method is we need the curve reflex. So
I have taken a real number 1 by 2 belongs to real numbers. Okay, my dear children, I have taken a real number 1 by 2. Then, what is the next step? We should write a statement, yes or no?
so 3x is equal to, so both are like factors.
Yes or no,
Yes,
my
sir.
dear?
Yes, sir.
How do you write this relation 1 by 2? I have taken only one single number 1 by 2. How to write the relation between A and B? A is also 1 by 2, B also 1 by 2. Okay, my dear children.
Okay, sir.
This is a relation between A and B, but in the place of B also I wrote 1 by 2. 1 by 2 is less than or equal to 1 by 2 whole cube. Okay.
Okay, sir.
1 by 2 is less than or equal to
So transposition method
1 by 8.
you find what you get.
Okay. 1 by 2 is less than or equal to 1 by 2 whole cube is 1 by 8. Is it a true statement or false statement? 1 by 2 is less than or equal to 1 by 8.
The true statement, sir.
False, sir.
False, sir.
Yes, false. False. Here numerators
False,
are same. Here numerators are same. Here observe the denominators. Here 2 is a smaller, 8 is bigger. In this case, the bigger denominator is a smaller number. The smaller denominator, that fraction is a bigger. But we got here in the reverse order. 1 by 2 is greater than or equal to 1 by 8, not less than or equal to. So here we got a false statement. 1 by 2 is less than or equal to 1 by 8 is a false statement. We can create infinitely many counter examples like this. Okay, my children. This implies we say that 1 by 2 comma 1 by 2 ordered pair. This implies that this relation is not satisfied. This condition is not satisfied. Means the relation R is not satisfying the condition of reflexive relation. Ordered pair 1 by 2 comma 1 by 2 does not belong to R. Okay, my children. Therefore, what do you say about this relation? R is therefore relation R is not. Therefore, our relation R is not.
Reflexive.
R is not reflexive. Now come to the next relation, that is a symmetric. Okay, my children. To check, the symmetric relation, or is whether it is a symmetric relation or not. Okay, my children. Right. Here, this relation R is not a symmetric relation also. That is why we give a counter example to show that a relation R is not reflexive. It is enough to give a counter example. Similarly, if it is not symmetric, it is enough to give a counter example to show that it is not symmetric. Likewise, if a relation is not that particular relation, we have to give a counter example. So let us take two numbers. Let
Then solving
2 comma 3. Let 2 comma 3 belongs to R. Okay. Yes or no? 2 is less than or equal to 3 cube. Is it true or statement or false statement? 2 is less than or equal to 3 cube. In the place of A, I wrote to 2. In the place of B, I wrote to 3. 2 is less than or equal to 3 cube.
True, sir.
True statement. 2 is less than or equal to 27. True statement.
Sir,
Yes.
sir, but 2 is not equal to 27, no, sir.
In the two conditions, any one condition can be satisfied. At a time, two conditions cannot be satisfied. 2 is less than 27 or not. Yes, it is less than. Okay.
Sir, we can also put false also, sir.
Yes, but in these two, less than or equal to, two conditions are there. Out of these two, any one can be satisfied.
Okay, sir.
So we can say that 2 is less than or equal to 27. Okay, my dear children. We have taken a counter example to show that given relation is not symmetric. Now let us change their positions. If we change the positions, what will you get? Or we take -2 also, -2. Okay, -2. Let us take -2. -2 is less than or equal to 27. I have taken A is equal to -2, B is equal to 3. If you write them in the reverse order, what you get here? In the place of B, write 3. In the place of A, write A. What will you get here? What will you get here? 3 is less than or equal to, in the place of A, again we are writing the reverse order, the same relation. In the place of A, we are writing 3. In the place of B, we are writing -2. At the beginning, we wrote in the place of A -2. In the place of B, we wrote 3. Just we are writing in the reverse order. 3 is less than or equal to -2 whole cube. Okay, my children. This implies 3 is less than or equal to -8. -2 whole cube value is -8. Is it a true statement or false?
Sir.
It is a false statement. Yes or no?
Yes, sir.
Is less than or equal to -2 whole cube is a false statement. This implies we say that ordered pair 3 comma -2 does not belong to R. Here we have taken ordered pair. Ordered pair -2 comma 3 belongs to R, but ordered pair 3 comma -2 does not belong to R. Yes or no? Here,
Yes, sir.
ordered pair -2 comma 3 belongs to R, but ordered pair 3 comma -2 does not belong to R. Then what can you say about relation R? It is a symmetric or not? Is it symmetric or not?
Not symmetric, sir.
It is not a symmetric. Therefore, relation R is not symmetric. And finally, we take transitive relation. To check the transitive relation,
Just stop here. 9x no 8x then. Then who got why Jordan suddenly said that 25 before?
let the three numbers. Let us take the three numbers. So A is equal to, let us take A is equal to 7, B is equal to 5, C is equal to 6 to the 6 power 1 by 3. Let us take like this, three numbers belongs to R. Domain. From the domain, let us take the three numbers. Okay. 7 is less than or equal to 5 cube. Yes or no? 7 is less than or equal to 5 cube. Okay. 7 is less than or equal to 5 cube.
Okay, sir.
This implies we can say that ordered pair 7 comma 5 belongs to R, because these two numbers are satisfying the given relation. Yes or no?
Yes, sir.
Next to 5, 6 power 1 by 3. Let us take 5 comma 6 power 1 by 3. 5 is less than or equal to 6 power 1 by 3 whole cube. Yes or no? 6 power 1 by 3 whole cube means you get 6 only. Yes or no?
Yes, sir.
So we can say that ordered pair 5 comma 6 belongs to 6 power 1 by 3. Ordered pair 5 comma 6 power 1 by 3 belongs to R. Ordered pair 7 comma 5 belongs to R. At the beginning we had taken here 7 comma 5 belongs to R, and here ordered pair 5 comma 6 power 1 by 3 also belongs to R. Yes or no? But
Then there was tomorrow we will see the fraction and subtraction. Then we will go for it.
it is a false statement. Yes or no? What is the A here? 7. 7 less than or equal to C means here 6 power 1 by 3. 6 power 1 by 3. Okay. 7 is less than or equal to 6. It is a false statement. It is a false statement. Yes or no?
Yes, sir.
This implies we can say that 7 comma 6 power 1 by 3. 7 comma 6 power 1 by 3 does not belong to R. Therefore, here 7 comma 5 belongs to R. 5 comma 6 power 1 by 3 belongs to R. If you observe, these two are link ordered pairs. Yes or no? 7 comma 5 and 5 comma 6 power 1 by 3. These two are link ordered pairs. What is the third ordered pair here? Ordered pair? But ordered pair 7 comma 6 power 1 by 3 does not belong to R. Yes or no? Therefore, relation R is not transitive. Therefore, relation R is neither reflexive nor symmetric not transitive. Okay, my dear children. Okay.
Okay, sir.
Once again, please watch this
Okay,
video.
sir.
Again, I will post this video one more time. Once again, watch this video. You can get the idea, some idea about this question. Will you do the next questions? Homework, my children. 7, 8. Homework.
Okay, sir.
Okay, sir.
6, 7, 8.
Okay, sir.
Please do the sums. 6, 7, 8. Please try these questions, my children. 6, 7, 8, 9. Okay.
So
Please
6, 7,
see
8, and 9, sir.
homework sums. Six, 7, 8, and 9. Please try the questions, my dear children. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children. Now you can leave
Okay, sir.
the class, my dear
Thank
children.
you, sir.
Thank you, sir.
Thank you, sir.
Okay, I will post this video again. Please watch this video again. Okay.
Thank you,
Okay,
sir.
sir. Thank you, sir.
Thank you all. Thank you all.
Thank
Thank
you.
you all. Thank you.
சரி சரி நான் அதான் பண்றேன் ட்ரெயின் கேட்பாங்க கடவுள் கேட்க மாட்டாங்க கடவுள்